Hey there, here's an electronics ramble. I've tried many times over the years to understand basic electronics. Most tutorials start with the usual Ohm's law, where the voltage is equal to the current times the sum of the resistance. This works great in theory, but what happens when the real breadboard's values don't line up? Especially when you want to get the current by dividing the voltage by the sum of the resistors. This drove me crazy until recently when I used AI to understand what was going on. First, let's look at a typical example. The voltage source is 5 volts. What the circuit is going to do is drop, or let's say shed, all 5 volts. That's what they do, drop the entire voltage amount by the way of the components. The resistor being used here is 220 ohms. If we measure the voltage across the resistor, we're supposed to get 5, or a voltage drop of 5. If we calculate the current using the formula, it should be 22.7 milliamps. Now if I create a circuit using a breadboard and a 5 volt source, let's see what happens. The first thing you'll learn is that components have tolerances, which means what they have on the label might not match what the meter reads. In most cases that's okay, but you have to be careful if you're building a very sensitive circuit. For testing here, it's fine. Our source is really putting out 4.97 volts. This means the voltage drop across the circuit should be 4.97, but here it's 4.96. It might fluctuate on the meter as the component warms up, but it settles out at 4.96. Tolerance. Now let's read the resistance. We're getting about 2.16.2 ohms. Tolerance. What about the current? It's 22.9 milliamps. It shows just 22 here, but I went back and changed the meter setting to do milliamps. So in the real world our values are a bit off than what's expected in the perfect world, but that's actually close enough to be okay. So don't tear your hair out, just use the mantra. Tolerance. Now we're going to add an LED. This is when you'll really want to scream. Let's compare the values to the previous ones. The voltage source remained the same, 4.97. So we should end up dropping or shedding this number. The resistor went up a bit to 216.8. Maybe it warmed up a bit or cooled down. I'll have to get an IR temperature reader sometime. Now let's look at the voltage drops. Because I added another component, the drops will automatically split over them, meaning the drop over the resistor is now less because the LED used some up. If we add them up, we get 5.06, which is a little over the source value, but that's okay because of, say it with me, tolerance. But now, let's calculate the current we expect. You'd think it would match the current on the circuit without the LED, right? But it doesn't. This is because LEDs are non-linear. I'll get back to this at the end. So here you are, playing with your circuit and meter, and thinking everything is making sense, until this. When you have a nonlinear component, what you must do when calculating the current is subtract the component's voltage drop value from the source voltage value. Then the calculation will match your meters. Surprise! So here's the useful information provided by the AI I used. If it wasn't for this, I would have thrown everything in the trash again. I hope this was useful to you. Please subscribe and let me know if you'd like more electronics videos like this one.